Today's topic that is about the multi-layer neural networks and backpropagation. And this slide just shows you some more details about the breakdown of today's lecture, and then I'm going to talk about the introduction, that is give you some brief introduction about what neural network it is, especially for the three-layer fully connected neural network, as well as the motivation of using the neural network. And then I'm going to talk about the feedforward neural network, and then we will take this feedforward neural network as a learning agent, so that we have a backpropagation algorithm, which is allow you to learn the connection weight of the feedforward neural network, so that you achieve some objective. And then another version of the neural network, we call this is the radial-basis-function neural network. And later on, I'm going to give you some more ideas by comparing the radial-basis neural network as well as the multi-layer perceptron neural network. And finally, the conclusion. Okay, so the introduction. Our goal for this lecture, that is to classify objects by learning the nonlinearity. Because when we do classification, we have a set of input. We are going to use this set of input to predict what kind of output it is. For example, +1, -1 for two cases. And then now let's have a look at the first point. The neural network that is inspired by biological neural network, that is our brain. Our brain consists a number of neurons. The neurons connect them together and then to form some knowledge, and then they communicate with each other to process the information, so that which is able to do reasoning. And then this idea that is shared by the artificial neural network. The artificial neural network, that is the network which is going to mimic the behavior of our brain. So we simplify the model so that we have the artificial neural network to process, to learn the knowledge and then process the data. And then in this lecture, we are going to use it for classification. So we are trying to connect the neural network with what we have learned in the previous lecture. For example, we have done the linear discriminant function. We focus on the term linear. It means that this function can only give you a classification boundary, that is a linear boundary. That means if we have something that is nonlinear, for example, if we would like to have a boundary that is circle, and then this linear discriminant function cannot do this. And then so the main problem is that if we are going to change this linear discriminant function to nonlinear function, and then it is alright. But the thing is that we do not have a very systematic approach to determine the nonlinear function, what nonlinear function, as well as their parameters. And then, of course, later on, if you really want to find this nonlinear function parameter, a brute force can be used. That means by quick search, we are going to exhaust all the combinations of these parameters. For example, we have a function z, that is the boundary. That is, for example, I call this as z, and then we have a function which depends on parameter 1 up to parameter 1000. For example, we have 1000 parameters. If we are going to do that by trial and error, and then it takes a long time. For example, if we are going to break it down into 10 discrete value, each one of them that is 10, and then that means in total we have 10 to the 1000 combinations. So it is very time consuming, so we are not going to do this. So when we use the multi-layer neural network, and then this multi-layer neural network, the good thing, the beautiful thing, that is it is able to form the nonlinearity. That means once we have the network is constructed, and then we are going to use the training data to train the parameters of this neural network, so that we are going to achieve our learning objective. So theoretically that can be done, and then how actually we are going to implement this learning algorithm, that is the backpropagation, we are going to talk about. So Another important thing when we apply the neural network, that is, we need to choose the network topology so that we are not going to overfit or underfit the learning. Yeah. So we are going to talk about this later on. And then now, when we talk about a neural network, for example, if we are going to have 3 layers, x1, x2 as the input, and then so we have a number of hidden loops, and then an output loops right here, fully connected, and then so that means when we present x1, x2 into this network, we are going to obtain a value of output z, and then so when you look at this network structure, parallel computing can be used, because when information is going to pass through layer by layer, and then so in order to speed up the training or the processing, we can use the parallel programming or parallel computation to improve the speed. Yeah. Another one, that is the distributed representation. It means that if we are going to treat this neural network as a bad box, yeah, we are going to treat this as a bad box, and then this is usually the approach we are going to do. We present some example to this neural network. We are going to learn the connection rate so that we are going to represent the knowledge. Now the issue is that when we distribute this value into this neural network to represent the knowledge, and then so you can see that this is the reason why I call this is the distributed representation. The knowledge is distributed into the network, but somehow it is difficult for us to understand what it means, because this is a black box, and also it is a good thing that is we do not need to have much knowledge about the problem, and then the representation is distributed over the network. But the bad thing that is we do not know what knowledge it is. Yeah, we cannot interpret what value of this connection rate. For example, this is 1.2. We do not quite understand what it means. Distributed computing, that is something to do with the parallelism, because all these parameters are distributed right here. That means we are able to compute node by node, and making use of the parallel computing to facilitate the output generation. Learning capability, the whole network, you will just find out that if we are going to construct the network in this particular form, this network is a kind of universal approximator. That means we are able to learn any input-output relationship in a compact domain to any arbitrary precision. Yeah. And generalization ability, it means that after the learning through the example, if we are going to present some new example to this neural network, it is able to give us z value to predict what value it is according to the new example x1 and x2. And then we're talking about the adaptivity. It means that when we are going to deal with some new problems, if we are going to change the network topology, the number of layers, the number of nodes in each layers, and then we are able to handle different kind of scenarios or different kind of problem. Yeah. So these are the characteristics of the neural network, and also this is the motivation why we are going to apply the neural network to different complicated real life applications. Okay. Now, when we talk about the applications, in the beginning, I mentioned that we are dealing with the classification problem, but actually, we can extend it into a wide range of applications. For example, just to name a few. The first one, that is classification. As I mentioned before, it could be speech, it could be handwritten recognition, or biosignal application, biosignal classification. This is the cardiogram of the patterns, a waveform right here, and then the output we have normal, abnormal. For example, this is +1, -1, or this is represented by a dot, represented by a plus. So this pattern classifier, that is the neural network. So we are going to train the neural network such that it is able to generate the boundary So using this boundary, it tells you whether the input is +1 or -1, or even we can extend it into a nonlinear boundary. This one is a piecewise linear boundary, and this one is a nonlinear boundary. Okay. Prediction, and then so that is another application. So this is a stock market price prediction. Assume that we have some historical data. For example, day 1, T1, we have this value. T2, we have this value. So if we are going to say using 3 days, T1, T2, T3, okay, so 3 days, which is going to tell you the next day what would be the value of next day market as the stock value of next day. 1 day ahead prediction. And then another one that is something similar, that is, we call this is the mapping or the function approximation. Now we have different dots, so that means when x, that is x1, we have y1, this value right here, x2, y2. So if we can just simply design a neural network which take one input and which is going to output y, that is the predicted value. Yeah. So this y, I put a hat right here, it means that this is the predicted value of y. So when we present x1 as input, this y hat should be this value. If we are going to present x2, the y2 should be the y hat value, the ideal values. Yeah. So this neural network can give you a line like this. This is the best approximate all these sample points. So we call this is approximation. So just try to connect something with the term I call the generalization. Yeah. So these red points right here, they are some scene example. So we know x1 is the input, y this value, that is output. But what about something in the middle? So if we are going to input something in the middle into this neural network, according to this curve, it will tell you what value of the predicted y it is. So this is the generalization. Yeah. Okay. So clustering, that is, if we have a lot of samples, a lot of data right here, and then so we can also use the neural network to tell you which class it belongs to by generating this boundary. For example, within this boundary, we call this the class 1. Within this boundary, we call this class 2, so and so. Yeah. So we will cover this clustering approach later on, and then this one we are going to use the unsupervised learning instead of supervised learning. And the next one, that is about the control. The control, we can use the neural network to do the control to form a feedback loop right here. For example, we have a car engine, and then so we are going to measure the output speed of the engine. This output speed, which is going to input it into this controller, represented by the neural network. The neural network is able to tell you what kind of throttle angle to control the speed. So we are going to have a feedback loop right here. According to the current speed, adjust the throttle angle so that we are able to achieve the expected speed of the engine. It is, yeah. So after we have some applications, and then I'm going back to what I mentioned before, that is the network topology. Yeah, because the network topology, it is something to do with the adaptivity as well as also depends on what kind of applications we are going to deal with. Yeah, so image processing, approximation, mapping, so and so. Yeah, but in general, when we talk about the network architectures or the structure, we can break it down into 2 types. The first one, that is the feedforward neural network. Yeah, when we look at the feedforward neural network, why it is called feedforward neural network? It is mainly because there's no loops. No loop, it means that when we present any input x1, x2, it will just flow through to the output. And then we are able to measure z1, z2 right here. Yeah. So, and also z1, z2 does not depend on the historical data. That is the previous samples we input to the neural network. Yeah. So we call this is the static system as well, because it does not depend on time t, the previous data input to the neural network does not affect the output of the current output. Yeah. So we have done the single layer perception network in the previous lecture, and then today we are going to learn about the multi-layer perceptron, that is the multi-layer neural network, as well as the radial-basis-function neural network. But another type that is not covered by this lecture, but it demonstrates a lot of applications in the field. Yeah, we call this is the feedback or recurrent neural network. The main difference, that is, we have loops. When you present x1, x2 to this neural network, the signal is not just flowing through the network. So when you look at this one, we are going to have a loop right here. And then when you look at this link, we have a loop right here. So Z1 and Z2, the output of this neural network depends on the data you enter previously, because the previous data will have a loop right here, so that this network, we call this is the dynamic system. The dynamic system has one issue, that is the network may not be stable. It means that because of this dynamics right here, if the learning algorithm is not good enough or the data is not learned well, the output may go to infinity, that is unbound. And then in this case, this neural network is an unstable neural network. Some examples of the recurrent neural network, that is right here, we have competitive neural network, we have some loops in this layer, as well as the self-organization map, and then usually that is used for image processing and hope field networks and the app model. All of them, we have loops. Okay, now once we have the network topology, that means we have a lot of network structure right here. How do we determine their behavior as what we expected? Say, that is, we have the weight corresponding to each link. How do we learn this weight so that we are able to achieve our goal? So it depends on the learning algorithm. The learning algorithm in general, we have these three types. The first one, that is the supervised learning. That means if we are going to have a neural network that is with two input, x1, x2, and then one output. So to learn the connection weight, W, that is, we need to prepare some data. We call this is the data set, the training data set, x1, x2, as well as the target. Yeah, the target, that is the value of z. Yeah, so that means, for example, when we input x1, x2, that is 1, 2, we expect that the neural network z, that is 3. Okay, just for example. And then so if x1, x2, that is -1, -3, the output, that is 4. So this is the example we are going to present to this neural network, so that the neural network will remember these data, these examples. Yeah, so that is the learning. We call this is the supervised learning. With particular input, we know the particular target output for this neural network. Yeah, so this is the target is known for every input samples or pattern. So this is the input patterns. This is the target. So this is the supervised learning. I'm going to talk about the details later on using the backpropagation. Another special type of this supervised learning, that is the reinforcement learning. The reinforcement learning, that is, we do not particularly provide the target output. For example, when we are playing the tic-tac-toe. So the computer pay 0 and then the player X, and then so whether we can use the neural network to learn my behavior or to learn the behavior of the computer. Say we are going to play X right here, whether this is a good move or not. And then so we do not use this kind of example, that means when we have the broad pattern right here, and then we will not say that this, when we put x right here, that is a good move, or whether we put an x right here, that is a good move. Yeah. So instead, we are going to use a reward function. That means after we compete this game, and then if we win the game, or the computer win the game, that is the agent, the learning agent wins the game, and then so we are going to give a +1 to indicate that this is a good move. If the agent loses the game, it is -1. So it will just tell you that whether this move is a right move or not. So we do not present an example. Yeah. So this is a kind of reinforcement learning, unsupervised learning. That means we will not provide the target value. We just present the input pattern into this neural network, so that this neural network is going to learn the underlying structure. For example, clustering, that is the one of the example. We will not tell which sample belongs to which class. The neural network determine or tell us which class that sample belongs to. Yeah. Hybrid learning, that is a combination of the supervised learning and unsupervised learning. So that means we are going to say some layers we are going to use unsupervised learning to find the connection weight. In some other layers we are going to use the supervised learning. We are going to talk about this in the radial-basis-function neural network. Yeah. Okay.